So this side is x plus 5. Over here we have VT. Since they're congruent, that's 2x plus 1. We know that WV is x plus 9. So we want to set our 2x plus 1 equal to our x plus 5. And then we want to solve for x. That's our first step. When we solve for x, I want to get my x by itself. So I'm going to subtract x to the other side. I end up with x plus 1 equals 5. Minus 1, minus 1. X equals 4. So I know here that x equals 4. Now that I have that, to find these side lengths, I take that 4 and I'm going to substitute it in. So we have 4 plus 5, which is 9. We have 4, let's see where we're at. WV, we have 4 plus 9, which is 13. Nice job. We have VT, which should end up being 9 because they're congruent, but we'll double check it. 4 times 2 is 8 plus 1, 9. So it worked out. And then over here, we have our other side. You know these two are congruent, so that has to be 13. With that, they want to find the perimeter. How do we find perimeter?
Your thing.
Yep, it's the thing. So remember, perimeters are outside, right? So it's how much fencing you're buying, not how much land you're covering inside that fence. So what we do is we add up all of our sides for our perimeter. So you have 9 plus 9 plus 13 plus 13. So I have, let's do it over here, 9 plus 9 plus 13 plus 13.
Yeah, it's 44.
44? I cannot write that on top of that line. Can you see it okay if I write it on top of that where it says 44? Okay. Our second question here, again, is already telling us that it's a parallelogram. So these questions tell you it's a parallelogram. They want you to know which properties you have. So we know what about angle relationships in a parallelogram. There was 2 properties that dealt with angle relationships.
Who called me?
Opposite angles are congruent and consecutive angles are supplementary.
Yep, so we have opposite angles are congruent and consecutive angles are supplementary. Okay, hold on 1 second. Jalen, please stop. Okay, so we're here. You have A and D. Are A and D opposite angles or are they consecutive angles? They're consecutive angles, which means that they're going to be, you just told me? Not congruent. Supplementary. So that means we know that if this angle is x, and this is 3x minus 4, that x plus 3x minus 4 equals 180. When I was walking around, I noticed that a few of you were setting your sides on question number 1 equal to 180. Remember, 180 is angles. So sides are not going to be 180. The consecutive angles are 180. Over here, we are now going to add those up. We have 4x minus 4 equals 180. 4x equals 184. Yes, Trey?
Subtract all the terms. Draw a line through that 4 and 180 between that.
Oh, you mean like this, and we add it to the other side?
Yeah.
Yep, that's good. You can do that. Thank you. Okay, so now that we're here, we're going to take 184 divided by 4. X, what did you say? 46. So we have 46 here. So we see that A has a value of X. So that means that A is 46 degrees. Which angle is opposite of A? C. Opposite angles are congruent, so that means that this has to be 46 degrees. We also know that consecutive angles are supplementary, so you have 2 ways of finding it. But let's go with direct substitution.
Did you mean to write that 46 right there on C?
I did, because opposite angles are congruent. Because I'm going to do B right now. That's what we're on. Yep. So right here, we see that 3x minus 4 is 3 times my x value of 46 minus 4. What's 3 times 46? 138 minus 4? 134. So B is 134. And you can verify this by adding 134 and 46, and you'll see it's 180. We have the measure of angle D equals 134. On question number, well, I guess this one's number 2. So on question number 2, find the perimeter of this parallelogram. So we know the opposite sides are congruent. So which two sides am I going to set equal to each other? E. So GF, yep, equals side opposite of it. EH, yep. So we know that x plus 8 equals 3x minus 2. We're going to subtract over our x. We get 8 equals 2x minus 2. Going to add 2. We end up with 10 equals 2x. We got to get x by itself. What do I have to do? Divide by 2. X equals 5. Okay. So now that we have 5, we want to find the side lengths. I only have to find the ones that are one of each, that are not opposite of each other. So I can find this side here. It's easy to substitute 5 in for x plus 8. So if I put that in here, I have 5 plus 8, which is 13. Up here, we know that this is going to be 2 times 5 plus 8, which is 18. We know over here this is 18. This is 13. Okay, so when we do this, we now just add all of these up, or you can multiply each side that's different by 2. So you have 18 plus 18 plus 13 plus 13. So we ended up with 36 plus 26. 62. So our perimeter is 62. In question 4, it has to deal with what is the sum of the interior angles of a quadrilateral. What does it add up to? 360. So what we're going to do is we're going to add the angles we know, subtract them from 360. So I have 91 plus 150 plus 46 equals. You guys said 287? Okay, so now I have 360 minus 287. 73. So we have 73. Okay, our next one, we have 90 plus 70 plus 82. 242. We have 360 minus 242. 118 degrees. Here, our first one. Is it a polygon? Are the side segments? Do you have anything that is not a straight line?
No.
On number 1? Nope, they're all formed by segments. Is it open? No. And then our second one is, does those segments overlap at all? Nope. So we know this is a polygon. Yes. So this is A. So yes, it is. And it says, if so, name it. So we want to count the sides. 1, 2. Give me 1 second. I'm not as quick as you. 3, 4, 5, 6, 7, 8, 9, 10, 11. Did I give you guys a name for a shape that has 11 sides?
And it's something after that. I forgot what you said.
So we have the word n-gon. And when we say n-gon, that is the side length. And then we put gon under it. So there's 11 sides. So we call this an 11-gon. It's an 11-gon. Our next one. Is it formed by segments?
No.
Is it closed?
No.
It is not closed, right? Those segments don't reach the endpoints. So no, it is not a polygon. It is because its segments is not closed, so not closed figure.
What's this a G?
It says to explain, so you have to put all of it. It's 11 gone, G-O-N. Okay, our number C.
No.
No, why do you know it's not? Yep, not segments.
I think I'm high now.
Okay, number D.
Yes.
Yeah.
Yes, we know this is. How many sides does it have?
4.
4. What type of quadrilateral? Hey, we're going to move over to number 7. I know that 6 is below 5. So we see that this is a parallelogram. We know that WB is 2x minus 1. So WB, right here, is going to be 2x minus 1. We know that TE is going to be 3x minus 14. And we know that BS is going to be x plus 9. X plus 9. Okay, so in a parallelogram, we know some facts about diagonals. What is the property we know about a diagonal? So they're bisected, so the two parts of a diagonal are congruent, but they themselves are not congruent to each other. So we know our red part here is going to be congruent to our blue part here. So WB will equal BS. So I'm going to set those two equal to each other. We have 2x minus 1 equals x plus 9. We're going to solve, so I'm going to subtract over x. I get x minus 1 equals 9. Add 1, add 1. X equals. Okay, now that we have x equals 10. And we look at this, we now want to substitute in to find our different parts. So if we want to find WB, we know that is this formula up here. 2 times 10 minus 1, which equals 19. So we're going to go down here. We're going to put 19. Our next one is TE. Oh, nope, BS. BS. So again, it's going to be that 10 plus 9, which she just told us is 19. Nice job. We have WS, which is the whole length of WB plus BS. Ooh. And so that's going to be, 19 plus 19, which is, you just told me, 38. Okay, we have TE, which is the whole length of the other diagonal. So we're going to substitute in. So you have 3 times 10 minus 14. Yep, 16. Thank you both ladies. So we have 16. We have BT, 8. And how did you know that? It's going to be 16 divided by 2 because those diagonals bisect each other. So that length of 16 is going to be cut in half, which means our last spot, BE, also has to be 8. Because we know that this portion here is congruent to this portion here. So when we look at this picture, what do we have? We have opposite angles. And we know opposite angles are congruent. So what can I do with those two? Yep, set them equal. We have 5x minus 6 equals 3x plus 28. I need to get all my x's on the same side, so I'm going to subtract my 3x to my other side. Working? I end up with 2x minus 6 equals 28. Got to get my 6 to the other side. Added. I have 2x equals 34. I need to get x by itself. What do? Divide by 2. I end up with x equals 17. With x equals 17, we're here. Now we want to find the measure of angle A. So up here in angle A, I know that's going to be 5 times 17 minus 6. What is 5 times 17 minus 6? 79. So the measure of angle A is 79, which means the measure of angle C should also be 79. We can verify this. We can substitute it in. You have 3 times 17 plus 28. When you did that, did you end up with the same thing? Yes, we do. Thank you. Okay, and then we want to find the measure of angle B and D. Do we have any variables in there for us to solve for? No, so how do we find those? Yep.
The whole thing is 360, so you have to subtract 79.
So we can do that, and that is a good way of doing it. So Janelle proposes that we know the whole thing adds up to 360. You take 360, you subtract 79, you subtract 79, and you're left with the two angles that you know are equal. So that whatever you get, you divide it by 2 and you split it. That's more than fine. We can do it that way. The other way of doing it is, you know, these angles are supplementary. Take 180 and you subtract 79 from it. So we can do it both ways. So her way has us doing, I'm going to do it in a different color so you can see it. You end up with 360 minus 79 minus 79. What did you get for that, hon? Is it 202? You get 202. That 202 has to be split between those two congruent angles. So you divide it by 2. You end up with 101. If you didn't want to do it that method, again, you could have done the method where you know that these two are supplementary, which means that you have 180 minus 79, which equals 101. Either one is okay. On question number 8, this one, there's several ways about going about this. When I look at this, I go back to the fact that it's a parallelogram. We know we have two parallel lines in either direction that you go, and they're being cut by a transversal. So if we look at this, we have two parallel lines being cut by a transversal. What do we know about this angle and this angle?
So do that mean 202 a perfect square?
It is not a perfect square. We divided it by 2. So we have these two. They're going to be congruent because they're opposite interior angles. So opposite interior angles are congruent. So that means that this has to be a 60 degrees. So here you see that these angles are congruent because these are your parallel lines. And it's being cut by that transversal. Now that we have that, to find the measure of W. What is the sum of the interior of a triangle? Because that's what we have. We have 180. So we're going to take our two angles we have, 60 plus 38, 98. We have 180 minus 98. We get 82 degrees. So W equals 82. So is a parallelogram? What did you guys say? Yep, it is. And how did you know it? Correct one. Yes, opposite sides are congruent. Both pairs of op sides are congruent. Okay, our next one. I'm going to go to E next. We're going to work first row, second row, third row. So here you see of the congruent angle marks. So is this one a parallelogram? Yes. And how did you know it?
Because both angles are congruent.
Yep. Yes, because both opposite pairs of angles are congruent. Okay, our next one. We see B. Is B a parallelogram?
Yeah.
It is. How do you know it? Other than we're on a roll, you guys just felt like.
The bisected.
Yep, our diagonals have been bisected. And we see that here. Our next one. Is that one a parallelogram?
That's a rectangle, man.
Yeah.
We cannot say definitively if it is a rectangle, but no, it is not a parallelogram. How do you know? So we see that our diagonals have not been. Yep, diagonals are not bisected. Our third one here, we see that we have 3 of our 4 angles. Is this one a parallelogram? How would we test? Yeah, Janelle? So that is a great strategy. So what she did is she added 72 because she knows if it is a parallelogram, it means the opposite angles are congruent. She added 72 plus 72 plus 118 plus 118, and she got a number bigger than 360. We know that can't happen. So that is one way of doing it. Another way would be going here. You know that consecutive angles add up to 180. 118 plus 72 is going to be 190. And that is not 180. No, consecutive angles are not sup. And then our last one on this part, are these going to be a pair? Is this one going to be a parallelogram? And how'd you know it? So you can see that 80 plus 50 do not add up to 180. That is true. Okay, so when we do this, we see that that does not add up. So you can say consecutive angles are not supplementary. You could also say that you see that opposite angles are not congruent. On D, what do we know about this figure? What do those arrows tell us? So the arrows do not tell us that they're congruent. They tell us something else. That they're parallel. And by the definition of a parallelogram, it is that opposite sides are. So you have 2 pairs of opposite sides that are congruent, but they're also parallel. So 2 pairs of parallel sides. So remember, you can use those 2 lines that are bigger than traditional ones to represent parallel. And then our last one here on this slide, is this a parallelogram? No. And how did you know it? Yep, opposite sides are not congruent. When we draw these, there are a few rules, but they do not have to be regular polygons that we're drawing. So you do not have to draw a traditional equilateral triangle. You know, it can be isosceles, it can be saline. You can do that with all of them as long as it is a closed shape, formed by segments, has the number of sides required, and they are not going to overlap. So, our first 3-sided shape is called a triangle. So, draw a triangle. It has 3 sides that are closed. We have a triangle. We have a 4-sided. What do we call that? Quadrilateral. Quadrilateral has 4 sides. So, connect 4 sides. Quadrilateral. 5. Yep, pentagon. Pentagon has how many sides? 5.
Somebody know.
Hmm. A hexagon has 6 sides. Seven. Seven-sided. This one's gonna be fun. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Octagon. 1, 2, 3, 4, 5, 6, 7, 8. If it helps you when you go to this large, you can number your sides so you see them. Helps me. Okay, after this we have a 9-sided object, which is a N-O-N-G-O-N. A, thank you. Okay, that's 9 sides. So we now have 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'll go through and label those for myself. 1, 2, 3, 4, 5. Give me 1 second. 6, 7, 8, 9. N-O-N-A-G-O-N. And our last one here, we have 10. Decagon. Decagon has how many sides?
I ain't drawing.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.